Okay, so let's start. So they will start gathering once we start. Good afternoon, everyone. Thanks for attending this session. I would love to introduce to you Dr. Mai AbdelShahid. She is a PhD in architecture and parametric designer, lecturer, researcher, and I know you are all excited about the AI. She is an AI art explorer as well. So we all are going to learn a lot from her today. And we are so excited. All of the students, they are so excited to hear from you. Thank you, Dr. Mai, for having from your time for our students.
Thank you, Dr. Iman. I'm so pleased to be here with you and with the students. And thanks for Sharjah University to host this lecture. I hope it will be useful to all the students, inshallah.
Thank you.
Today, the lecture is about design with intelligence. So how we can unlock the potential of parametric design with the artificial intelligence. As students of interior architecture, you are all aware of the importance of good design. But today, everything is fast. So it's not enough to have a good design. It's important also to have a creative design and efficient and sustainable and also cost-effective. The parametric design help us to do this, to gather all these tools together in one modeling or in one project that we can apply every thing in it, inshallah. Now we are stumbling upon some of these curvilinear fluid forms, which are spread in the recent years after using the parametric design. These examples has form and texture and pattern and has its own design process to end up with the final shape that match the design criteria. The goal of the design could achieve the sustainability, as we said, controlling the amount of light, for example, controlling the heat, or find an optimized structural system that is made of recycled material, recycled timber, for example, and will be digital fabricated, maybe as one of the methods. So when exactly did parametric design enter the architectural field? The first application was the sketchpad. It was used in 1957. Then ArchiCAD is introduced in the history as a first CAD program. Then it helped the architects and the engineers and the designers to draw 2D and 3D drawings. Then in 1993, the boom that happened when using the algorithms thinking or the algorithms in the works of Frank Gehry and Zaha Hadid. They based their design on the algorithm or the scripting and programming language which they used at that time, C# to make these fluid and deconstructivism shapes. Until Revit is released in 2000, which was the beginning of the BIM object, and the appear or the tools we can use the parameters and the variables such as the walls relationships and the location of the doors and windows. And in 2007, Dr. Robert Woodbury called the term parametric design on the smart geometry that afterwards many books and research explain the parametric design and made the designs we see nowadays. The applications now are very competitive in various fields, in architecture, interior design, sculpture, and the manufacture of cars, even the sport shoes. Until also, at the last, we are seeing the artificial intelligence. Artificial intelligence and machine learning are used in the past. They are used in the construction, but now it's available now for all the users we can use, like an end user or a normal user. I can use the artificial intelligence to transform a text into images. Let's start. What is a parametric? The word para is a prefix in a Greek language, which means two objects has relationship together. A simple example we can explain this meaning is our hand movement. We will see the fingers are related to each other. When we move one finger, the other moves, respectively. And each finger has certain angles as constraints of movement. These relationships called system. So it achieves two types of system, like it's a part-to-part system and part-to-whole system. Any system is composed of a number of components, and the components together composed this system. So we can consider the parametric design as a dynamic, evolving geometry, while the static geometry consider the form as a group of shapes, lines, points, vertices, separated from each other. So let's ask a question now. If we look to these two chairs, how can we differentiate the chair that is made parametrically or the chair that is not made parametrically? We can have just 1 minute to think, or just think on it, if it's on the left or the right. Actually, both chairs here are not parametrically built. Here we can move each part separately. We can move each slice in a place and it's not related to any other chair. So here, it's not about the form, it's not about the shape. We can make a complex shape, we can make a simple shape, but it should be built with parametric rules and relationships. Here, the same two chairs, but are controlled with variables and parameters. We can change here the chair, the size of the slices, the end section and the last section, for example, the thickness of the slice, each slice, everything is changed as a whole system, not each part separately. The other chair also is related together. We can change its height, we can change the thickness of its legs and the back of the chair also. When I move the point, the base point that make the width of the chair, everything is changed together. So it's a whole system moving together. Whatever the software we will use, we should have something that's called computational thinking. Computational thinking, it's like a Lego assembly. It helps us to think how we can solve a problem or how can we build the form that we want. First thing is to decomposition. The decomposition means that to make everything to its simplest form, to make the assembly to the parts that we have. Then the second step is pattern recognition. The pattern recognition is to see how the patterns are repeated or how they are arranged together, or which shape should I start with and what is the next step. Then the abstraction. If we have the most complex form, so we have to abstract it to its basic shapes to start in its modeling. After that, the algorithm, which is the last step that we use to make the steps and the rules and the relationships between the shapes to get the form. Now we can see a lot of software that are used. I started in my master's with generative components, but Autodesk later developed some software with like Revit, Dynamo, Inventor. But the most used now is Rhino and Grasshopper because they have a lot of plugins and they have a large library we can use to help us in the modeling, and even the architect or the designer without the programming background. Here are some examples of the plugins we can use in Grasshopper. For example, here these are the structural analysis, like it's called Kangaroo and Caramba. We can use also the environmental simulation by Ladybug and Honeybee. We can use also the paneling or the tessellation or pattern subdivision using Lunchbox, Starfish, and Parakeet. And this Lunchbox, for example, is not only for the pattern, it has also machine learning tools and other tools that is very helpful in architecture design or interior design. This is the interface of Rhino, because I will talk about Rhino today, Rhino and Grasshopper. This is the interface of it, the modeling here, the modeling space, and here is the Grasshopper interface. Now Grasshopper is a part of Rhino. it's not a plugin, it's inserted in the latest versions of Rhino. So here we can see a lot of wires, lots of nodes. Maybe it's scary a little bit, but no, it's once we use each node in its place and define each part, then it's easy to trace the wire to know which command is related to which. And then so at last, after we finish all the software, we find our form is fully controlled and we can change it and have lots of variations that can be generated from one script like this. Some of the constraints that we might use in the modeling, for example, that we keep the relationship perpendicular or parallel, or keep it horizontal or vertical or tangent. Like here, for example, I have 3 lines. The first line, which has the dimension, the first line is double the second line and it's half the horizontal line. So this is a relationship. It's always fixed. When I change the length of one line, the other line is changed accordingly. This can help us in the golden ratio, for example. We can see here, we can make a line and keep the golden ratio between the lines. And there is a tool in Grasshopper called golden ratio. It calculates automatically where is the point that that makes the golden ratio. So when we start here, this is a simple example to start a form. We start with the points. As we said, the point is the simplest form and it's the basic point. If I started with the curves and I change the curve, or I divide the curve into points, and at the points we construct a plane on it to generate sections, and then we get the loft between these sections, and then we subdivide the loft, whatever. Even if I change the curve, the original curve, now everything will change accordingly. We can put bricks, for example, as a subdivision. We can put any pattern, maybe Islamic pattern, anything. We can subdivide the surface with it. In this example, the form, it's like a complex form. It's a surface, and I will try some different subdivision on it. Mainly, any surface has like U and V lines, which is the horizontal line and the vertical line that compose this surface. So, for example, I started with the Voronoi to subdivide this form. Then after that, I started using the diagrid in Lunchbox. And after I divide it, I give him a rule to show the depth of the wood, or the depth of the sections, to see the form of it. And then I used a contour line, and we will, sorry, this is the hexagonal pattern, the same surface. I just changed the wire direction from one node to another. Here also the contour, and we can see a lot of walls and bench, chair, examples of these contour sections. We know that every section afterward has a number, and it's digital fabricated and located at its place to reform this this modeling in real life. Here is the contouring, and this is called, if we use the U and V direction together, this is called waffle structure. This looks like a waffle. Here, this is another example for the fractal in parametric design. This is an application of my PhD, because I tried to use fractals to model the Mamluk Mosque. It's based on the Mamluk Mosque because they had fractal characteristics. And then I tried to generate more variations if from the Mamluk Mosque based on this property. The actual examples you can see in the buildings now, how we use the parametric design to achieve some sustainable goals. Here we can see the application of parametric design. In the first example is 𝗵𝗿𝗺𝗺𝗵𝗆. This is an eco tower based on dynamic intelligence skin in a large scale building, not a pavilion. The outer shell is used in the style of Islamic geometry. They took it from the 𝗨𝗶𝗶𝗵, and it covers 3 sides of the building except one side, which is the north side, which is not exposed to the sun. And the pattern is also mechanically controlled with sensors. It feels the light that can penetrate, how much light is needed to penetrate the building inside. And at night, for example, it's fully open. So this idea helped to reduce the energy consumption by 50% of the energy of both the towers. The second example here, the 𝗵𝗿 headquarter in Sharjah. I don't know if you go there or not, or if it's built there. I think it's.
We have just went there last week. Just.
Oh yeah.
Yeah.
Is it nice? And sure, it's nice.
It's amazing. It's amazing building, and they felt how the curvy sand dunes transferred into a real building. So it's an amazing example for parametric design.
Inshallah. Mashallah. This example is very good. Yeah, especially in the lobby. I wish to go there actually. In the lobby here, they made the skylight in the shape of gradient triangles. Then we can see how it increases in some parts and decreases in other parts. So here it's obviously to see that this part we need more sunlight, for example, above the stairs, and the other part we don't need the same penetration of sunlight inside. Another example is 𝗨𝗹𝗺𝗶𝗃. And this is the how I try to imitate the pattern. It's just every pattern is started from a grid and a pattern inside it. Then we scale, we control the scale by something called an attractor point. And this attractor point has a relationship with each pattern, with each triangle. So I said, if the point is far from this triangle, make the size bigger. If the triangle is near from this point, make the size smaller. It's like a relationship between all the triangles together with the certain point or attractor point. It doesn't matter to be a attractor point only. It could be also attractor SP line or attractor curve. The other example here is 𝗨𝗹𝗺𝗺𝗃. It used a multi-layered lattice in roof structure, and it makes reduced the sunlight penetration to 1% of the exterior sunlight. So it helps a lot to decrease the heat inside the building. The Stadium of 𝗨𝗪𝗔 used 2 types of patterns here. We can see the rhombus gradient pattern here, and on the top, the designer used the Fibonacci ratio to make it like a flower shape in the ceiling, and the openings upstairs, or the opening above here, we can see that it's also gradient from big size to the small size. And this Fibonacci is used in the inner decorations of the domes in the mosques. Here it's a trial to imitate also, or try to decompose this pattern, how it's used. It's started from 2 circles, and the 2 circles are related together with these arcs, and then the attractor points start to move to determine which part that I need the most sunlight to go through. My sister likes the grasshopper script, so she's doing laser cutting interior parts. She applied it on this mirror with different variations also. So once a script is done on grasshopper, it's easy now to use it as a large scale in a building, or a small scale like a mirror or any furniture at home. The other example is for 𝗨 but it's based on the structure and material. It's called Morpheus Hotel. We can see the bracing from outside, and the interior of this hotel is amazing also. So to sum up, what are the benefits of the parametric design now? We can see it has efficiency to create more design. and use algorithm to generate variations, lots of variations of one design. It's very flexible to adjust or modify at any time if the client said, oh no, I don't like this. So it's easy to save time and to adjust the modification. It's also customization, which meets the other needs. We can see problems that happens during the construction process. So if there a problem came up, we can change everything. The iterations and the variations, the optimization, like we can we have a specific set of requirements such as material efficiency or structural stability or energy performance. Here, the sustainability can help designers create more sustainable designs by optimizing the environmental performance, reduce waste, minimize the use of resources. And at last, the collaboration, which is we can collaborate with the stakeholders and the contractor and the engineers and with the clients. The whole framework become more strong. We will move now to the artificial intelligence. Actually, it's widely used in the parametric design and the interior design. But today, as a start, I start with two applications, how we can use the artificial intelligence in the parametric design. We know that we see now Midjorney in variations in everything, the Instagram, in LinkedIn. Every artist tried new ideas according to his background or just to imagination, what everything we can imagine in text-to-image programs or software. So now the artificial intelligence will help a lot the design process. And we can see some software like Midjourney, 𝗨𝗶𝗀𝗺𝗏, Stable Diffusion, and Blue Willow, and a lot others. I tried all of those except the Stable Diffusion. Some has some advantages and other has disadvantages. Everyone, but maybe Midjourney still is the best of them until now. It gives a high quality of images and surprise us with the variations or the results that appears. How can we write the artificial intelligence? So it's a prompt. It's a list of words or sentences that we can use. Sometimes I see the prompt of other artists, they wrote like 1 page or half page of description of the prompt. So for us as an architect or designers, we can divide the prompt to 10 parts. If we can use it's like we use the keywords to highlight or to check with the AI machine to get from its library. For example, I need from the library of 𝗨𝗪 project, if even in the buildings or interior design or furniture. So I write 𝗨𝗪, for example. Then what type of the building that I'm going to do, or what type of furniture that I'm going to model, or I want to see its images. So if it's chair, if it's bench, every word count. Every word is different, make different results. So we can try many variations. We can try to make different places also. Sometimes if we write certain country is different from another country based on the library of the images in each country. Type of art, for example, we can use neoclassicism, expressionism, cubism, for example, Regency, any style. We can write also to take from its vibes. And some fancy, I call it, some people call it material testing, but it's like fancy blend. We can use the silky, we saw silky layers and feather, and cotton, chocolate. We can use anything, or even some people made interior inside trees and inside caves. Everyone tried lots of ideas, and actually this is cultivating the imagination to all the designers. Then we use the environment. For a building, we can say river, lake, beach, or if we are interior design, we can use the bedroom, living room. composition. These are the last 3 points here is for the image quality. After I start writing my prompt, so I said, for example, I need a rule of thirds to make the photo balanced. I need a foreground, I need a background. For example, the background could be a cave wall, not a normal wall. The foreground, I need a vase, a focus on a vase with flowers. So it's like the art, how the photo will result. And then we can use the view also, if it's top view, front view, aerial view, for the designer's elevation, sections, everything is there. And also the type of the drawing, if I need a sketch, if I need a 2D drawing, if I need a render drawing, a real photo, everything is available. And at last, the photo quality, I use the 4K for the resolution of the photo, or 8K HD to enhance. Sometimes I saw people use 32K, and it actually affects the quality of the image, but it takes so much time to generate it. Here is it, the most thing that I like in Midjourney, that the gallery they have. It's like a community. All the users are together in the community. Everything. Some people could share their arts if the subscription of them is public. Some people is private. If you want to make something, not to share it with others. But the gallery is full of examples and full of. You can see here, if I write the word interior only, all the photos that based on interior and how they write the prompt is there. We can see here how they use different, like cave and bedroom in a cave. It's a good idea. And then we can use here lush vegetation. We can see also on the right the hashtags, the floor plan. If we click on the hashtag, it gives us also another results of which users use this hashtag. You can see here, this photo shows the sketch. It's like a sketch interior. Here another example. If I write a parametric, all the parametric examples there appear. Some people, you can see some artists use adjectives like pink, some inflated, use wool, for example, luxurious gold. Anything I want to add in the interior design, I can put it in the prompt. It's most important to use the adjectives. The adjectives, if you there is a guy here, use the the mushroom and the dragon and the seashell, the same object by different adjectives. It gives us a lot of variation, as you see: melted, crystalline, frozen, gel pens. Everything gives different results. So how can we start in Midjourney? After in the beginning, it gives you like a trial version, 25 images. After that, after subscription, you can choose which plan to subscribe in. Here, we start with the word imagine. It's backslash and imagine. Then the photo came up with 4 variations. It has under each photo the U1, U2, U3, U4, which means make it a bigger size, or V1, V2, V3, V4, which make a variation of each photo. For example, U1 for the first square. So I choose one. It takes some time here, although it's written fast, but it takes some time to generate the photos. For example, I wrote interior photography for swirling parametric patterns, modular, using a timber and silky from properties, and then 8K HD. These were the results. So if I like it, okay, I can go with it. If I don't like it, I can regenerate another 4, and until I find what I'm looking for in my imagination. For example, the second square was good, so I upscale it to a larger size to use it later. Okay. Here the same. I'm still just changing some words. Here, for example, another variations appear here. I just wrote, maybe I just add pavilion, for example, or interior. Each word gives us different variations. And now it's more smarter because lots of users use parametric design and use some of these keywords. The machine itself learns a lot, and it can enhance the results. Every day you can see good results in Midjourney, for example. I'm talking about it. So when we tried the first versions, it wasn't like these results from the first time. You can see a good image and good proposal. This is an example for if each variation here, this my Islamic architecture, every variation here gets 4 other variation, and every variation here gives other variation. It's important to be very selective here, not to go with every variation. Just choose 1 or 2, because we can go on a non-end or take lots of time to choose the variation that you want. So I started with 2, for example, and at last I found these 2 results are very good. How to use it in the parametric design? It has the property that you can make a sketch. You can start by hand or make your sketch and insert this sketch inside the Midjourney. And then after you insert the sketch, you can write any prompt you want. Like here, you put the image. After we put the image here, we take the URL of this image, and we can write, for example, I wrote here, parametric, colorful 3D rendered pattern with different heights. This was the result. So maybe if I wrote another keywords, other results can come up, and then it helps us in imagining the 3D space of the sketch that we made. Other example that we can start with the artificial intelligence to make something that the design criteria want. It's like here, it's like pavilion or station, the interior of a station, with also parametric models. So I tried many examples until I was comfortable with the one on the left, and started to model it. So we will start to make the computational thinking in this part. How we can make it? We are going to start with the simplest form. How can this form is built? It's built with 2 splines, the rail, okay, and the section of it. So I draw the section and the spline, and then make the whole structure that is made from it. You can see here, we can change the number of the vertical supporters. We can change also the horizontal supporters, the number of them. It's all controlled. Here is the first image from the Midjourney. So this is the final project. It's abstraction from it, because in Midjourney it's more complex. You can see here in the background more complex shapes, but it gives us or gives me a clue how to make a design, for example, in this space. These are other examples. If you can try other patterns or the characteristics. For me, I prefer to use the natural characteristics like fractal in the Islamic pattern. I'm trying to see what could happen if I used both terms together, and I'm always surprised by the results. Actually, these are some of the pictures in my Instagram. There are lots of more for the variation that came from these 2 terms together. So we can sum up that how we can benefit from the AI plus the parametric design. If the parametric design can cause good efficiency, so the AI gives us increase this efficiency and get more accuracy and more iterations, lots of iterations that we can use. Better communication. If you have some clients, you can show them precisely what he wants or precisely the design that he needs, and we get a common idea together. Then it helps in also to make creativity and cultivate our imagination. It increases also the customization. And just to remember that to use the computational thinking, it's not just on the software, it's to use it in our life. It helps a lot in solving the problems. And then I try to sum up everything. I hope this lecture is helpful to the students and to you, Doctor.
Thank you so much. Wow, this is really interesting.
Thank you.
Yes, you opened their imagination a lot. We were afraid, as we discussed, to open the floor for the students to use the AI or not. And definitely we cannot just prevent it because it's everywhere. No one can prevent it. But it's about how to utilize it, how to use it in a proper way, to utilize it to serve your own projects, to open your imaginations more and more. I believe it's a big difference within the quality, within the options and alternatives we are going to have from the students. That was really interesting, and I believe we have many questions. So we'll open for the questions. Anyone have a question, please open your mic and go on. Any questions about the parametric design, about the Midjourney? Are you comfortable using it within your designs?
Thank you. All is clear.
You don't have any questions, all of you? Okay. I believe, yes, it was so clear. We have just finalized the parametric design yesterday as well, and I promised them that we are going to learn a lot today about the AI and how to include it within our projects, the coming projects. And I believe you might be one of the jurors then for the final project to see how they are working or utilizing the AI within their designs. Thank you so much for your time. Thank you for your time for the University of Sharjah, and we really appreciate your support, and we really enjoyed all what you have done with the AI and with the parametric design.
Thank you, Doctor. Thank you. It's my pleasure to be with you, and I really enjoyed being with the students today. Thank you so much.
Thank you so much. I believe maybe they will have questions, but later they are shy to ask. But I look forward for your all questions.
Anytime. Okay. Thank you. Thank you so much. See you. Bye bye.